What is the chi-square test of independence? When do we perform this test? And how to perform this hypothesis test? In this video, we will try to understand that. Let's say there are two categorical or nominal variables and we want to know whether the two variables are related. For example, let's say there is a movie hall. Certain categories of movies are shown here. People go there to watch movies and they buy snacks sometimes. Now, let's say the owner of the movie theater wants to determine the number of snacks to buy. So, he wants to know whether the types of movies have any relation to the number of snacks people consume while watching the movies. We can perform a chi-square test of independence in this case to determine whether these two categorical variables, types of movies and consumption of snacks have any relation. But before we perform this hypothesis test, we need to create a contingency table that contains the observed counts of each category and summarizes the data. Let's consider the following contingency table for our example. Please note that to perform the chi-square test of independence, we need to meet certain criteria. There should be two categorical variables, there should be two or more groups for each categorical variable, the expected frequency should be at least 5 for the majority of the cells. In this example, we follow the first two criteria. We will test the last criteria while performing the test. So, let's go ahead with our hypothesis. Our null hypothesis is that there is no relationship between the two categorical variables. In other words, there is no relation between the type of movie and the number of snacks consumed. And the alternative hypothesis is that there is some relation between the two categorical variables. In other words, the type of movie and the number of snacks consumed are not independent. Let's also assume that the level of significance is 0.05. Firstly, let's calculate the expected frequencies for each cell. The expected frequency of a cell is given by Eij is equal to Oi into Oj divided by n, where I is the row number, j is the column number, Oi is the corresponding row total, Oj is the corresponding column total, and capital N is the total sample size, which is 500 in our case. So, for the first cell, that is for the row of the action movie and the snacks column, the expected frequency is Eij is equal to Oi into Oj divided by n, that is 200 into 190 divided by 500, that is 76. For the row of the action movie and no snacks column, the expected frequency is Eij is equal to 124 after calculation. Similarly, we can calculate the expected frequencies for all other cells. After calculating the expected frequencies of all the cells, the contingency table looks like the following. Please note that the numbers in the brackets denote the expected frequency of that cell. So, if R is the total number of rows and C is the total number of columns, then in our case R is equal to 3 and C is equal to 2, and the total number of cells is equal to R into C, that is 6. The test statistic in the chi-square test of independence is calculated using the following formula. Test statistic is equal to chi-square is equal to summation over I and j Oij minus Eij whole square divided by Eij. Here, I takes the values between 1 and 3 and j takes the values between 1 and 2. Oij is the observation for the cell with ith row and jth column, and Eij is the expected value for the cell with ith row and jth column. For example, for the first cell with first row and first column, Oij is equal to 80 and Eij is equal to 76. So, Oij minus Eij whole square divided by Eij is equal to 0.213 after calculation. Similarly, we can calculate the value of Oij minus Eij whole square divided by Eij for all the cells and sum them up to get the value of chi-square. In our case, chi-square is equal to 1.509 after calculation. This test statistic follows the chi-square distribution as shown in the graph, and the shape of the chi-square distribution graph depends on the degrees of freedom. So, we need to look at the chi-square distribution table to find out the critical value. The degrees of freedom is equal to number of rows minus 1 into number of columns minus 1, that is 2 in our case. Here is the chi-square distribution table. We will look at row 2 and the column for alpha is equal to 0.05. We get the value 5.99. Our test statistic is 1.509, which is less than the critical value of 5.99. Hence, we fail to reject the null hypothesis. So, we can conclude that there is no relation between the type of movie and the number of snacks consumed. I hope this helps. Interested viewers who want to know more, please visit the website of the Security Buddy or refer to the playlist Statistics for Machine Learning. The relevant links are provided in the description. You may also want to subscribe to us and get notifications on recent videos.